Okay, so today we'll start with the next lesson on trigonometry, and this is dealing with that is known as the sine law. So let's kind of review what we did yesterday and then move on to a more in depth to the sine law. Let's suppose that we have the triangle ABC, as you see it in here on the picture, and this triangle has three acute angles. First of all, let's clarify what acute means. Acute means less than 90 degrees. So what it is saying, angle A, angle B, and angle C, they are all less than, individually less than 90 degrees. And what we are doing here is using SOHCAHTOA, we will determine the length of BC. So now as you see angle A, from angle A, from the vertex of angle A, when we draw the perpendicular to BC, this will divide angle A in two angles, one of them being 20 and the other one being 55 degrees. Now, when we take a look at this triangle and focus on what we are looking for to figure out is BC, then we can say that BC is equal to this segment here plus this segment here. For simplicity, what we will do is we will label the vertex of the 90-degree angle as letter D, let's say. So now, in order to figure out the length of BD and the length of DC, we have to kind of break it into two triangles. And those triangles being A, B, D. So A, B, D. This is 90 degrees, and this angle here is 20 degrees. The length here is 12.50, and the triangle ADC, so where angle C is 35 degrees, and this one here is 55 degrees. And again, D is the right angle triangle. So now, using SOHCAHTOA, we will deal first with triangle ADB and then with triangle ADC. I will give you like 1 minute to deal with it. Okay, so hopefully you will have this work here. And what we have done is we have divided those two triangles, and on triangle ADB, which is this triangle here, we found what is BD initially, because this is what we are looking for. But when we move to the other triangle, we have nothing besides the two angles. So then that means that we have to find one of the sides in order to use the trig ratio, sine, cosine, or tangent. So then the only thing that connects the two triangles is the length of the line segment AD. So then using again the same triangle ABD, we will find the length of AD, and then this length is 11.74 centimeters. And then on triangle ADC, then we move to the next triangle. Tangent of 35 is AD over DC. And then from here we find what is the length of DC. And adding the two together, the DB and the DC, we will figure out that the length of BC is equal to 21.07. Now, if you haven't used tangent 35, you have used tangent of 55, then you should have the same answer as 16.78, but in a different way. Okay, so what we are dealing now is a triangle that is not a right angle triangle. As you see here on the initial triangle ABC, none of the triangles were right angle. None of the angles were right angle 90 degrees. This is 75, this is 35, and then this one here will be whatever is 180 minus 75 minus 35. So they are not, none of them is a right angle. Therefore, makes the triangle ABC a non-right angle triangle. So in the trigonometry of non-right angle triangles, what you will see is a triangle similar to the one that we saw before, or similar to this one here. In the triangle ABC, this triangle that you see on the picture, the side that is opposite to the vertices of the angle is assigned with the lower case of the vertices. So the side BC is assigned with letter A. And this is letter A, lowercase a. The letter B, lowercase b, represent the opposite side of angle B. So AC will be B or B. And now you get it. For angle C, the opposite side, AB, is represented with a lowercase c. With this in mind, we will express what the sine law is telling us. So it's saying that the ratio between sine of the angle and the length of the sides that represent the angle, opposite to the angle, is the same in a given triangle. So sine A over A is equal to sine B over B is equal to sine C over C, or everything is inverse A over sine A equals to B over sine B equals to C over sine C. And in order to know this law, to apply this law, you must know one angle and the corresponding side. So you have to know one complete fraction, one side of the fraction, either sine A over A, or sine B over B, or sine C over C, or the inverse of them. And then, in order to use this, you have to know either the side or the angle of the other fraction. So on the triangle ABC, which is the triangle that we started with on this lesson, angle A, which initially was divided into two, 25, 20, and 55 degrees, now it's given as 75 degrees. And another angle here is 35 degrees. And what we are doing is we are looking for what is BC. So now, what do we know here is we know C. Okay, the length of AB, which is the opposite of vertices C or angle C. And what do we look for is what is A, or the opposite of angle A, 75 degrees. So Let's solve now for using sine law. So the way that we will apply sine law will be, keep in mind, it is sine A over A is equal to sine B over B is equal to sine C over C. What are we using are those two ratios. So we can rewrite them as a sine A over A equals to sine C over C. So sine, if we substitute now, 75 over A is equal to sine 35 degrees over 12.50. From here, we can find that A is 12.50 times sine 75. The whole thing, this is multiplied, the whole thing divided by sine 35 degrees. And now with the help of the calculator, what we will do is 12.50 times sine 75. Make sure that the mode of your calculator is on degrees. Divide by sine 35. And we have what we 0.05 centimeters. What we actually found on the first slide of this lesson, or on the first part of this lesson, but in a very short way. And now let's see how can we solve the indicated side on the examples that we have here. So we have the triangle ABC. One angle is 41 degrees, one is 73 degrees, and we are looking for the length of BC, which is, being the opposite of angle A, is the lowercase a. And as a given is the length of B, which is 8.5 centimeters. So now the sine law is saying sine A over A is equal to sine B over B is equal to sine C over C. What do I have to use here is sine A over A is equal to sine B over B, because those are the two sides that we are dealing with. So this will be same as saying sine A sine of 73 degrees over A, which is unknown, is equal to sine 41 degrees over 8.5. From here, we find that A is the same thing as we did before. Oops. I don't want it this big. Here. So 8.5 times sine 73 divided by sine 41. Okay, so will be 12.A will be 12.39. A will be 12.39 centimeters. Let's take a look on the other example. We have again the triangle ABC, and what we know is what is the length of side A, and what we are looking for is the side B. So again, using the sine law, change the color now. Using the sine law will be sine A over A equal to sine B over B. Let's substitute what we have. So sine 108 over 12.9 is equal to sine 24 over B. From here, B will be 12.9 times sine 24, the whole thing over sine 108 degrees, which when we use the calculator, we'll have 12.9 times sine 24 divided by sine 108 equals to 5.15, if I'm not wrong. Okay, so let's take a look at the other one. On those examples, what we will do is we will find the missing angle. So triangle PQR, angle P is 92 degrees, and the side, or the opposite side of angle PQR is P, lowercase p, and what we are looking for is what is angle Q. Okay, this angle here. And the opposite side of angle Q is given as Q 19.8 meters. So let's write the sine law as sine P over P is equal to sine Q over Q. So this will be sine 92 degrees over 28.6 equals to, we don't know what Q is, over 19.8. And what we will do on this case, we'll solve for sine Q. So sine Q will be equals to 19.8 times sine 92 degrees over 28.6. With the help of the calculator, we'll go 19.8 times sine 92 divide by 28.6. 0.6, and will be 0 point. So this is the sine value. In order to find the angle, what we will do is inverse sine of the answer. Again, inverse sine of the answer. So the angle will be 43.78. So angle Q will be 43.78 degrees. I hope that you understand. And let's move to the next one now. So next example is triangle STV. And what we are looking for is angle V, knowing that the opposite side of angle V is lowercase v, 169 millimeters, and the opposite side of angle T is lowercase t, 262 millimeters. So let's write the sign below as sine t over t equals to sine v over v. Oops. And substitute it. So sine 117 degrees over 262 is equal to sine v over 169. From here, sine v will be 169 times sine 117 degrees over 262. By using the calculator, let me fix this. Using the calculator, we'll have 169 times sine 117, enter, divided by 262, enter. 0.5, so this 0.56, I will write this down so that you have it, 0.57, and so on. And in order to find the angle, what we will do is inverse sine of the answer. You don't have to write everything. So then from here you find that angle V is equal to, what was it? 35.1. 35.1 degrees. Now we have another example on triangle ABC. The angle A is 49, angle B is 57, and A is 8. Calculate B. So we don't know how the triangle look like. This gives us the liberty to draw a triangle. Any way that we want to. So I will draw it in this way, ABC. And this angle is 49 degrees. This angle is 57 degrees. This length is 8, and we are looking for B. So again, sine A over A is equal to sine B over B. Substituting, we'll have sine 49 over 8 equals to sine 57 over B. From here, we can find that B is equal to 8 times sine 57 over sine 49 degrees. So B will be, let's plug this in the calculator. So 8 times sine 57 divided by sine 49 will be 8.89. So 89. Now we have another example. A surveyor measures a baseline PQ to be 440 meters long. He takes measurements of the landmark R from P and Q. He finds that the angles are given like this. Before we move forward, I want to just clarify what that means, what this sign here means. So it is the angle sign, and then you have three letters. Up to now, we kind of have reviewed and said that the angle is with one letter, but then suddenly you see it with three letters. There is nothing to panic, because the way that you will read it is like this. So you start at P, you go, sorry, Q, P, R. The angle that is formed is this one here. So the letter in the middle is the angle, or the other one, P, Q, R, which is this one here. So if this is 75, this one here is 46. And then what we have here as a given is that the length PQ is 440 meters. So this is 440 meters. But PQ is the opposite of angle R. So this is lowercase r, which we don't know the angle as per now, but we can figure it out because the sum of inside angles in a triangle is equal to 180. So what I'm saying here is angle P plus angle Q plus angle R is equal to 180 degrees. From here, we find that angle R is 180 minus 46 minus 75 degrees, which again, with the help of calculator, we can figure out 180 minus 46 minus 75 equals to 59 degrees. So this is equal to 59 degrees. So now we have the angle that is opposite to what is given as 440 meters. Now, one more thing that we have to add here. They're asking us to calculate the perimeter, and the perimeter is the sum of all the lengths of the triangle. So it is PQ plus QR plus RP, which means that we have to find what is PR and we have to find what is RQ. So let's start with the first one as what is, let's suppose, PR, which is with a lowercase q. So sine q over q equals to sine r over r, or sine 75 degrees over q that we are looking for equals to sine 59 that we just found over 440. So q will be equals to 440 times sine 75 divided by sine 59. 495.83. 95.83 meters. And then we will look for the length P or QR. So now again we'll use sine law. So we'll have, now we can use anything, but I recommend you always to use what the problem is giving you instead of what you are finding, because what you are finding may be a mistake, but then this mistake is carried over. So I will say sine R over R is equal to sine P over P. So sine R is sine 59 over 440 equals to sine 46 over P. From here, P will be 440 times sine 46 sine 46 over sine 59. So P will be, using the calculator, making sure that the mode of the calculator again is on degrees, 440 times sine 46 divided by sine 59 is 369.25, 365 or 69, 69. Point 25. 369.25 meters. And the perimeter, of the triangle will be 440 plus 495.83 plus 369.25. So perimeter will be, let's write perimeter, 440 plus 495.83 plus 369.25, 1,305, 1,305 meters. Okay, this concludes today's lesson. Now, you can practice on the textbook. I will post the textbook on D2L as well, and you can see the questions. And if you have the questions that are marked here, if you have any concerns, question, or problem with solving the questions on page 138 to 141, let me know and I will try to help you make a Zoom session or something